From the southern tip of Spain, Africa shimmers on the horizon, just 9 miles away, yet a world apart. The Strait of Gibraltar is a narrow ribbon of water unconquered by bridge or tunnel. Despite our technological feats, bridges spanning seas, tunnels through mountains, this crossing remains elusive. Why, with all our ambition, have we never connected these two continents? The answer lies not just in engineering, but in the story of humanity itself. For centuries, this strait has been a stage for empires, explorers, and myth. The ancient Greeks called the peaks on either side the Pillars of Hercules, the edge of the known world. Today the monsters are not mythical but geological and oceanic. The dream of a bridge is as old as our desire to unite what is divided. We see a gap and want to close it, a barrier, and want to tear it down. The Strait of Gibraltar is more than a physical divide. It separates cultures, economies, and histories. To span it would be a symbolic act of unity, a declaration that we can overcome any obstacle. But first, we must understand the true nature of the challenge, one written in the very bedrock of the earth. This is not just a story of engineering, but of our relentless spirit and our humbling limitations. The strait is a reminder. Some boundaries are set by forces far greater than ourselves. Yet the dream persists, as powerful as the currents that flow beneath. The question is not just if we can build the bridge, but if we should, and how. The answer begins with understanding what stands in our way. The story of the Gibraltar crossing is a mirror, reflecting both our ambition and our respect for the planet. And so, the mystery endures, as deep as the waters below. Imagine a high-speed train gliding beneath the waves, linking Spain and Morocco in minutes. Such a connection would unleash immense economic promise, goods, people, and ideas flowing freely between Europe and Africa. For Morocco, it's a direct artery to Europe. For Spain, a gateway to Africa's growing markets. The dream is not just economic, it's about people, culture, and opportunity. Tourists, students, and families could cross with ease, weaving two rich tapestries even closer. The idea of a fixed link is not new. Engineers have dreamed of it for over a century. Governments have invested millions in studies, knowing the first to bridge this gap will make history. The symbolic power is immense, a physical manifestation of unity in a divided world. Bridging Europe and Africa would send a message of cooperation and shared destiny. In an age of global challenges, the Gibraltar crossing is a beacon of hope. It's a project that looks to the future, where continents are connected by human ingenuity. But the dream is only the beginning. The reality is far more complex. To understand why it remains unbuilt, we must look beneath the surface. The Strait of Gibraltar may look calm, but beneath lies a world of hidden violence. Here, the Atlantic and Mediterranean collide, creating fierce, unpredictable currents. A river within a river, moving in opposite directions. These currents can reach over 6 knots, forming whirlpools and eddies that challenge any construction. Building foundations here is like working in a permanent, invisible hurricane. The strait is also incredibly deep, nearly 900 meters in places, far beyond the reach of most bridges. The pressure at these depths is crushing. The seabed is unstable, layered with soft sediment. Anchoring a structure here would be like building on quicksand. The combination of violent currents, extreme depth, and shifting seabed creates a perfect storm of engineering challenges. Even the Golden Gate Bridge, an icon, stands in water only a fraction as deep. Traditional design simply won't work here. Nature has conspired to make this crossing almost unbridgeable. Yet the challenge is not just technical, it's a test of imagination. To conquer the strait, we must rethink what's possible. The forces below are relentless, but so is human curiosity. The next obstacle lies even deeper, in the restless earth itself. Beneath the strait, two tectonic plates collide, the African and Eurasian. This is an active fault zone, prone to earthquakes and constant geological change. Building across a fault line means designing for tremors and the possibility of catastrophic shifts. A major quake could snap a bridge or collapse a tunnel in an instant. Engineers would need unprecedented flexibility, materials and designs that bend, not break. The region's history is dramatic. 6 million years ago, the strait closed, drying the Mediterranean. Then, a cataclysmic flood reopened it. The ground here is always moving, if only by millimeters each year. Over a century, that movement adds up. Structures must endure on a planet in flux. The Earth is an active participant in this story, its power impossible to ignore. Any crossing must be built not just for today, but for a shifting tomorrow. The challenge is as much geological as it is human. We look to engineering marvels for inspiration: the Channel Tunnel, the Second Tunnel, the dream of a Messina Strait bridge. The tunnel proved we can tunnel beneath the sea, but its geology was far simpler than Gibraltar's. The Tacoma Narrows bridge collapse taught us to respect wind and unseen forces. The Seikon Tunnel in Japan showed it's possible to build in earthquake zones, but at shallower depths. The Messina Strait project, still unrealized, faces similar challenges: deep water, seismic risk, and technical limits. These stories offer lessons and warnings. Ambition must meet reality. Even with modern technology, some gaps remain just out of reach. Each project pushes the boundaries, but Gibraltar demands a leap beyond anything attempted. The strait is a testbed for the next generation of engineering. To succeed, we must learn from both triumphs and failures. The solution may require a new kind of thinking altogether. The strait is not just a challenge for engineers, it's a lifeline for marine life. Whales, dolphins, and countless fish migrate through these waters. Construction could disrupt their ancient roots. Underwater noise and pollution threaten species that rely on sound to survive. The strait also supports vital fisheries and local economies. Building here risks damaging sensitive ecosystems and spawning grounds. The environmental cost could outweigh economic benefits if not carefully managed. Any project must put nature at its heart, biologists and engineers working side by side. New techniques and strict timing could minimize harm, but some designs may be too disruptive to consider. The challenge is not just to conquer but to coexist. Our ambition must be matched by wisdom and compassion for the planet's other inhabitants. When bridges and tunnels fail, engineers imagine the extraordinary: a submerged floating tunnel. Suspended in water, anchored by cables or pontoons, it would float below the waves, avoiding surface storms and deep currents. This design could flex with earthquakes, absorbing shocks instead of breaking. Norway is already testing similar concepts in its fjords, proving the idea is not pure fantasy. The tunnel would be built in sections, floated out and connected underwater, a colossal feat. Challenges remain, ensuring tethers last, preventing collisions, and guaranteeing safety for millions of travelers. But this approach marks a shift, working with nature, not against it. The technology is young, but the vision is bold. The floating tunnel could redefine what's possible beneath the sea. It's a glimpse of a future where engineering adapts to the planet, not the other way around. The Gibraltar crossing is ultimately a human challenge, demanding unprecedented international cooperation. Spain and Morocco must lead, but the project would need global partners: financial, scientific, and political. The first bridge to build is one of trust and shared vision. No single nation can shoulder the cost or complexity alone. A new model of partnership, public, private, and international, would be essential. The world's best minds must pool knowledge, sharing discoveries for the benefit of all. Open collaboration is already underway but must scale up dramatically. The real test is not just technical, but relational. Success depends on consensus, commitment, and a shared respect for the strait's fragile environment. Before steel and concrete, we must build lasting bonds of cooperation. The Strait of Gibraltar remains unbridged, a symbol of both separation and connection. Its missing link is not failure, but a measure of our wisdom and patience. The dream persists, passed to each new generation of thinkers and builders. Future solutions may use technologies we can't yet imagine: self-healing materials, autonomous robots, or something entirely new. The story is unfinished, its most exciting chapters still unwritten. The strait forces us to weigh ambition against responsibility, to consider consequences for the planet and all its life. It is a mirror reflecting our capabilities and our limits. The barrier is physical, but also philosophical, a line that makes us pause and reflect. So we wait, we study, and we dream. We imagine a day when continents are joined not by conquest but by harmony with nature. The unbuilt bridge is filled with hope and the enduring power of human ambition. Some dreams are so grand, they are worth waiting for. The strait's greatest value may be in the questions it asks, and the future it inspires.